Okay, so let us continue our solutions. In this next few exercises, we have to establish these identities using the angle sum formulas that we have already seen. We have so far seen two formulas in the text, but I have in fact prematurely told you about the other things also. That is, we already know these things. Sine of a plus b is sine a cos b plus cos a sine b, and the other one we know is this cosine of a plus b is cos a cos b minus sin a sin b. And additionally, we also know these things. Sine of minus a is minus sine of a, and let me write it here. Cosine of minus a is simply cosine of a. So cosine of a is the same as cosine of minus a. The sine of a means sine SIGN, okay, positive or negative, that thing. It does not have any effect on the cosine value of it. Now, what I have already, or what we have already seen, is that one can use these two along with this to find similar formulas for sine a minus b and cos a minus b, which however is in the text we are not supposed to know that yet. Assuming that we don't know such formulas, for example, we do not say no what cos a minus b is. That is, what I am trying to say here is that we do not yet have the formula for cos a minus b. So here, in deriving this identity, what we are going to do is that we will just use cos a plus b formula. In place of a we would take x, of course, and in place of b we would take minus pi over 2, and then let's see why I am doing this. It's because the formulas for sine a minus b and cos a minus b, they are coming next in an exercise. We have, however, in some of the previous solutions of the previous exercises, we have already used those things, but if you want, you can also do those exercises without using sine a minus b and cos a minus b direct formulas, and instead you can approach them like this. So let's see the solution. So the point here is that we do not know what cos a minus b formula is. Still, we can proceed like this. We have so we are going to just simply use this one. Minus pi over 2 minus, because it is after all a plus b, b is minus pi over 2, so that's why minus sin x sine minus pi over 2, and our calculation continues. Now in the next step, you can do one of these two things. Either you can directly try to find what cos minus pi over 2 is from the definition of cosine, which has that unit circle and all those things. Else you can use this formula. So according to this one, cos minus pi over 2 will be just cos pi over 2. Okay, so let's just use this one. it's also not advisable to always fall back on the definition all the time, because sometimes you have and ultimately you have to learn to use the formulas to your advantage. The more you can use the formulas and the relations, the faster your calculations will be. So let's just use these things here. So that means this is equal to cosine of x times cosine of pi over 2, and then if you use this one, this will be minus sine pi over 2. That minus and this minus would give you plus sine x sine pi over 2, and this thing equals, now we know what cos pi over 2 is. It is 0 and sin pi over 2 is 1. So that means it is sin x. So that's how we have sin x, which is what we wanted to show. Now if you follow the other the other thing that I said just now, that is without using these things, and you say you would use the actual definition, what would have happened then? This is your unit circle. Okay, so first you have to locate the angle minus pi over 2 radian in its standard position. When you put an angle in the plane, in the coordinate plane in standard position, its initial ray coincides with the positive x-axis, and the final ray of course will be determined by the sine as well as the magnitude of the angle. The magnitude here is pi over 2, but the sine is negative, so that means this amounts to clockwise rotation through an angle pi over 2. So this is your initial ray, so it rotates like this, and the final ray rests here in this position, because this much is numerically it's pi over 2, but because your rotation is clockwise, it is minus pi over 2 radian. Okay, keep that in mind. Whenever we do not mention the unit, it is always radian. If you want to specifically mean degree, you have to write degree. Fine. And then our usual procedure, we then see, so this is our final ray, initial ray, after it suffers this after the other ray stops moving, so this is the final position, so this is the final ray of the angle. Now the final ray intersects the unit circle at a point whose coordinates we already know, and that is 0, minus 1. And this tells us what? This tells us that according to definition, this x coordinate is the value of cos minus pi over 2, and the y coordinate is the value of sine minus pi over 2, and that is why cos minus pi over 2 is 0, whereas sine minus pi over 2 would be minus 1, and that minus 1 and this minus has actually they have given us plus, so that's why we are having sin x. So you can use either of these two things. So that's just the end of this solution. Let's see the next one now, because the next few exercises will be somewhat same. Let's just do it here itself. The next one is this, and here in place of sin x, now we have minus sin x. So if we accordingly modify this solution, what shall we get? Now we are having our actual cos a plus b, where no negative things are involved. So it's just simply It is just simply this. Now if you can just directly use the values of these quantities that you already know. However, still, where are these values coming from? From the definition, of course. Now your angle is positive pi over 2 radian. So your initial ray, of course, it just simply is this itself, the positive x-axis. However, because the angle now is positive, so your rotation will be counterclockwise through an angle pi over 2. That means the amount is pi over 2. So now this is your final ray, and that final ray intersects the unit circle at a point whose coordinates are 0, 1, and that is why cos pi over 2 is 0, because that is the x coordinate by definition, and sin pi over 2 is 1. So that is why now what do you have? Cos pi over 2. So we do not need this next step. We can now directly write so this becomes 0, this becomes 1, we are left with minus sin x, minus sin x. So that's how we have our result, 32. Next, 33. Okay, now this time instead of cosine we have sine. And what is the identity? The identity is this. This is now equal to cosine of x So let's again modify this itself, but now we have to modify a lot because the function itself has changed. Sin x plus pi over 2, so we are going to use this one. Sin x sin pi over 2 plus, see, this is how we make mistakes. Cos pi over 2 plus cos x sin pi over 2. Now this of course is 0, cos pi over 2, sin pi over 2 is 1. So that's why we are now having cos x. So this is equal to cosine of x. Next, 34. Naturally, now they are going to change this to minus, and that will now turn to minus cos x. So here also let us accordingly change things. We have minus, but keep in mind we do not yet, we are assuming that we do not know any direct formula for sin a minus b. So we have to proceed like the first one. So this will be sin x cos minus pi over 2 plus cos x sin minus pi over 2. And we can, in fact, if we just simply use the definition, then from the definition itself we can see that cos minus pi over 2 is this 0. So this term would not be there. Sine minus pi over 2 is minus 1. So here we will have minus cos x. Minus cos x. And now only after going through these first four do we come to the next things where we are actually going to see what the formulas are for sin a minus b and cos a minus b in general for any a and b. For general a and b, however, it's difficult to use the actual definition, and we won't need the actual definition here. I mean, we of course need it because the quantities are defined by the actual definition, but we won't need the definition to know some special values like how we proceeded here. So the next one, 35. Here we have to prove that cos a minus b is cos a cos b plus sin a sin b. We have cos a minus b. In order to emphasize the fact that we are actually using the formula for cos something plus something before writing anything else, let's just write this. Okay, now we use our usual cos x plus y formula, like how we were proceeding here. I mean, not exactly in this one, but the other ones. Cos a cos minus b minus, in the original cos formula there is a minus in between, sin a times sin minus b, and you stop here and then write. Now we know that cosine of minus b is the same as cosine of b, and sine of minus b is minus of sine of b. Hence cos a minus b. When you in anything, whatever you do in mathematics, when you write something, say you write a sequence of equalities, like what you normally do when you are going through a calculation, and you need to stop it somewhere, then say something about the quantities involved, and then you resume your calculation. When you do that, it's advisable to write the first thing and then the last thing, because you do not need to again write the intermediate stages of the calculation. They are already there above. Now you just use this result, that cos a minus b is this thing. Cos a cos minus b minus sin a sine minus b. But now because cos minus b is just cos b, so you write cos a cos b. And here the minus sine b and minus first, it will become plus sine b. And after practicing enough this type of things, you can in fact afford to not write this also, because here also we are writing something again. You can directly write this equal to this plus sine A sine B. In fact, ideally, if someone is really hell-bent on showing everything in detail, one would also write another step where you do have cos A plus cos B, but then minus sine A times minus sine B. That, however, it is up to you to decide what you have to do. If the situation is really extremely complicated, then it's better to write everything in detail and go as slowly as possible to avoid making mistakes. But this is not such a very complicated situation, so we can just simply do things like this in a somewhat sketchy manner. Sketchy at this stage. Okay, then the next one. Sketchy from the point of view of someone who is doing this type of calculations for the first time. Sine A minus B is sine A cos B minus cos A sine B. Here also, so this time around we are not going to explain that much, we just simply write we have sine A minus B equal to sine A plus minus B, that of course equals this sine A cos minus B plus cos A sine minus B. If you want, if you are solving this as a standalone problem, then you need to write these things. But however, because we are going through a sequence of problems in this exercise set, so we can just simply use whatever we have written here and directly write sine A cos B, because cos minus B is cos B, and minus sine minus B is minus sine B. Yeah, so now we have the formulas for cos A minus B and sine A minus B officially. Okay. Next. What happens if you take B equal to A? That's a special case where in the identity, okay, so in the formula for cos A minus B, Does it agree with something you already know? You may have noticed one thing, not about these exercises, but you may have noticed that I left out two graphing exercises before. I mean, the two graphing exercises are still there that I left out. Today we have just simply started from what comes after those graphing exercises. That's because it's justified, since in those exercises we are asked to do things like this. Say you are asked to draw the graphs of these two functions together in one of them in a given interval for x, and then say something about is there any relationship between the values of cos x and the values of secant x that you can see from the graph. So for that you have to have the graph. Now I could have just simply drawn the graphs here roughly so that we can solve the problem, but it is left to you because I want you to go to this site where, of course, I have already said a number of times about this site where you can draw graphs. You just supply the equation and the graph will instantly come out. So there you draw these two graphs, and I want you to see for yourself how the graphs look and what can you say about is there any relationship between the values of these two functions. We already know the relationship because these two functions are just reciprocals of each other, but what do you see from the graph? So that's the exercise. So those things I want you to go on your own. If B is equal to A, then we get this. We know that cos 0 radians is 1. But 0 is a minus b if b and a are the same thing. And now if we use our formula, then we get cos a cos b. I'm just simply writing the formula the way it is. Okay, and then we are again, of course, going to use the fact that a is equal to b. In place of b, I'm just simply writing a. So that means we are having cos squared a plus sin squared a, which is 1. We already know this. So you can see that this familiar relationship or identity that you already know from, in fact, from your introduction to trigonometric functions. The very first thing that you know is this identity. So this identity is a special case of your cosine a minus b formula when b is equal to a. another one such. What happens if you take b equal to 2 pi? Okay, so this time we are taking a special value. In the angle sum formulas. Do the results again agree with something you already know? These other formulas that have been derived today from the angle sum formulas, these other things cannot be called angle sum formulas because a minus b is not a sum. Of course, you can object and say, you can argue that no, a minus b is a sum because a minus b is a plus minus b. But that's not what we are talking about here. So why I am saying these things is because we need to know what the angle sum formulas means, and that is just simply sin a plus b and cos a plus b. I mean, the appearance itself has been used to give them that name, angle sum formulas. These other formulas, if you want, you can call them angle sums, but they do not, I mean, at first glance they do not look like sums. That's what. So here it just simply means the ones which have plus, the plus sign or the plus operation. If, okay, or we can write, we can start like this. Instead of writing if b equal to 2 pi, we can just directly write like this. We have what? Sin a plus 2 pi equal to sin a cos 2 pi plus cos a sin 2 pi. Then again the question of these values comes. So you can just quickly find them from the definition. The definition looks quite complicated when one encounters it for the first time, but the more you use it, you see how easy it is. What is the angle 2 pi? Let's see. So this is our initial ray, and because the sign is plus, there is no minus, so the rotation will be counterclockwise rotation. pi over 2, pi over 2. That means this much is pi, and then another pi. So here, for this angle, the initial and the final ray coincide, and that's why this itself is the final ray, and it intersects your unit circle at this point, whose coordinates are 1, 0. So that's why cos 2 pi is 1 and sin 2 pi is 0. So you are getting cos 2 pi is 1, so that means sin A, and sin 2 pi is 0, which is this term of course would just simply vanish because of that 0. Now, does this remind you of something? Yes, of course, it reminds us of the fact that the sine function is a periodic function with period 2 pi. So you need to write that thing. Okay, I'm not going to write that thing here. Okay, you can just simply write this shows, or you can in fact write those things once you have written the similar thing for cosine also. So let's just do the next calculation, and also let's put a comma here. Cos A plus 2 pi is, keep in mind we are now writing the formula for cosine, so cos A cos 2 pi minus sin A sin 2 pi, but again of course because cos 2 pi is 1 and sin 2 pi is 0, this term vanishes and we are having cos A. So both sine and cosine are periodic functions with period 2 pi. So that's just it. So once you write that, it's over. Let's solve a few more using the angle sum formulas. Now, how do you use those things? So there is a kind of a little heading, using the angle sum formulas. And under this heading you have these things. In exercises 39 through 42, express the given quantity in terms of sin x and cos x. So the 39th one is what? Cos pi plus x. We just directly use the formula cos pi cos x minus sin pi sin x. Okay, so we now need these values cos pi and sin pi. Use the circle. Your angle pi, for that angle, if you put it in your standard position, then this is your initial ray. The final ray is this one, the negative x-axis. So this much is pi, because it's positive, the angle is positive, the rotation is counterclockwise, and it intersects the unit circle at this point, whose coordinates are -1, 0. Keep in mind that this 1, -1, these things are coming because the circle is a unit circle. So all these distances are 1 because the radius is 1. So that means cos pi is -1 and sin pi is 0. Sin pi is 0, so this term would not survive. Cos pi is -1, so we have minus cos x. Now we are often advised to, again I am repeating this thing, okay, I have already discussed something about this, about remembering this type of things. Again I am repeating because it's very important. It's very important to not blindly memorize these things. So instead you can just, how long does it take for you to figure this out, that cos pi plus x should be minus cos x? Not very long, just a few seconds. Instead, if you just blindly memorize a long list of formulas, then it's highly probable that you would forget many of them, and even the ones that you remember end up being incorrect somewhere. Say you forget a minus. So it's always, not just here in mathematics, it's always important to know and always remember to not just not just keep the information in your head, but it's more important to know how one gets to that information, what the route to that information is from other things which are easier and more elementary. How one derives more complicated things from elementary things, that root is what matters. That's what you have to remember, because elementary things are easy to remember, of course, complicated things are difficult to remember. But if you remember the elementary things and you remember the route to the complicated things from the elementary things, that is the derivation process or the proofs, roughly, then you will see that you actually remember many things, and you understand also what is going on and what everything is. Okay, next, I have in fact one point been told to memorize such tables which had many formulas like this: pi, pi over 2, 2 pi, in fact 3 pi over 2 also. But that is just pointless, according to me at least. Sin 2 pi minus x. Now that we have the formula for sin a minus b, officially we can directly use it. We have sin 2 pi minus x equal to sin 2 pi cos x minus cos 2 pi sin x. Sin 2 pi is 0. You can see that, there it's written sin 2 pi is 0 and cos 2 pi is 1. So that means this will vanish, and here you will have minus sin x. Then Let's keep that figure for now. Another thing that I should perhaps mention, which is not exactly related to anything specific, is that you see the words easy, difficult thrown around all the time, not just in mathematics, but when it comes to learning something, these words are thrown around here and there, and you see people asking things like, is this easy? Is this difficult? These questions also have no meaning. With enough practice, you can make anything easy for you, actually. No matter how complicated the thing may look at first glance. That's because you don't know that thing. So you persevere, you learn, you go through all the things. Of course, it's painful, but there is a gain also, no? And once you come out, after some time, you will see that you are becoming more and more well versed with the things to the point that it becomes natural to you. So then it becomes easy. Then 41. Sine 3 pi over 2 minus x. Sine A cos B minus cos A sine B, and this is why I kept that circle. 3 pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. So this is the final grade, and the coordinates of this point are 0, minus 1, 0, minus 1. So cos 3 pi over 2 is 0, but sine 3 pi over 2 is minus 1. So that means minus cos x. That's just it. Next, cos 3 pi over 2 plus x. We have cosine now, and also we have plus. Fine, that's not a problem. We have, not even writing we have anymore. Not that you should not write, I am just simply making things faster. Cos A plus B. Cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. So again, cosine of this angle is 0 and sine is minus 1. So that minus and this minus would become plus and would give us sin x. In 43 it's a little different. Here we have to calculate an actual value. Evaluate, we don't have any variable here. Evaluate sine 7 pi over 12 as, so this is not a standard angle by any means, as this, but even this some other values, I mean some other angles, for them also you can calculate the values of the trigonometric functions using the sum formulas as this, because you obviously see that this sum is 7 pi over 12. Pi over 4 plus pi over 3, that equals sin pi over 4 cos pi over 3 plus cos pi over 4 sin pi over 3. Because these are actual standard angles whose trigonometric values we knew even before this general definition came, so we can just simply write them. For example, sin pi over 4 is 1 over root 2, and cos pi over 3, pi over 3 radians is equivalent to 60 degrees, and cos 60 degrees is 1 over 2. Cos pi over 4 is again 1 over root 2, and sin 60 degree is root 3 over 2. So this thing becomes what? 1 plus root 3 divided by 2 root 2. Okay, from the look of it, I think you can modify it a little. It's enough if you just simply stop here, but can you, no, let's just leave it like this itself. Why bother anymore? That's the value. Then 44, here also we want to evaluate something similar. Cos 11 pi over 2. However, some such revelation is not given. You have to figure out how to calculate this. So it's up to us. If you think of it, you would eventually notice that this is 6 pi minus pi over 2. Do you see why? Because if you take 2, if you take 1 over 2 outside, you would be left with 12 pi minus pi, so that is 11 pi. Again, your cos a minus b formula. So that is cos 6 pi cos pi over 2 plus, because we have minus, here we would have plus, sin 6 pi sin pi over 2. Now you do not have to exactly know what cos 6 pi is, because cos pi over 2 is 0, so this term anyway vanishes. However, what is sin 6 pi? We have already seen what sin 6 pi is. In fact, sin n pi is 0 if n is any integer. But let's see that directly from the definition also. Again, your initial ray, so you have to now see what the angle 6 pi is. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So again it comes back to the same position as the initial ray, and the coordinates are 1 comma 0. So 1 comma 0, that y coordinate is the sine value, so this is 0. This one is 0, cos pi over 2 is 0, sin 6 pi is also 0, so ultimately this is actually 0, cos 11 pi over 2. And in fact there is one other way of looking at it also. One can, if you want, you can directly see what this value is from the definition itself, because the angle is 11 times pi over 2. So this is your pi over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that means the entire angle is going like this, and eventually the final ray is this, the terminal ray that intersects the circle at this point, whose coordinates are what? 0 comma minus 1, and the cosine value is the x coordinate, so that is why it is 0. But of course, because we are in this system of exercises where we are supposed to use the angle sum formula, so that's how we are just doing it. This won't always happen. For example, here you cannot directly conclude anything from the definition itself, but this is an instance where this is possible. Then in 45 we have to evaluate what? This is just simply cos pi over 12. Keep in mind that these evaluations are becoming possible. That's because not only are you using, or not only are you being able to use the sum formulas or difference formulas, but because once you whatever angle is given, that angle can be expressed as a sum or a difference of two standard angles. That's why all these things are possible. In general, if you just simply arbitrarily take an angle, then you may not be able to do anything useful if you just are using these methods only. That's how actual mathematics looks. Not saying that these are fake mathematics, but the thing is that the exercises that you see in any book on any part of mathematics at any level does not matter whether it is a school book or a college book or a research level book. Unless it's an actual research paper, the exercises that you see there are most of the times cherry picked to show how a given method can be applied to certain cases. The actual mathematical world does not care about these methods. You encounter something, then you just think of what you can do with that thing. And very often it's the case that one or two such methods will not work. So there you have to develop something new. That's how actual mathematics works. Now pi over 12 is, if you look carefully, just this. Pi over 3 minus pi over 4, because 4 pi minus 3 pi is pi and you have 12 in the denominator. So cos pi over 3, cos pi over 4, you have minus, so here you will have plus. Again, it's like that one. Sin pi over 3 is this. So this is, are we getting the exactly the same thing? Cos pi over 12, and there we had something like this, no? Cos 11 pi over 2, or no, that other one, sin 7 pi over 12. So the values are exactly the same. Just to see one thing, that in that problem we had this, no? Sin 7 pi over 12. Now can we express this in terms of just pi over 12 and some integer multiple of pi? So that I can show you why these two things are equal. If I can't quickly figure it out, I will just leave it. I cannot write 12 minus 5 because that does not give me anything useful. No, let's just leave it. I thought I would be able to show using only the sum formulas why this value is equal to sin 7 pi over 12, but it's left to you, say. I could not see anything immediately. And finally, let's just solve one more. Sin 5 pi over 12. Sin 5 pi over 12 can be written like this. Okay, now I have to think. If I do it like this, then I would have pi over 12, but with both sine pi over 12 as well as cos pi over 12. Okay, but if I actually apply the, okay, let's just see what happens. This becomes pi over 2 minus pi over 12. Okay, so if you apply your formula sin a minus b, minus cos a sin b. Okay, now this part vanishes because cos pi over 2 is 0 and sin pi over 2 is 1. So that means we are getting cos pi over 12, for which we already have the value. So that's why this is ultimately just this. And let's just end things here for tonight. We will solve more. Quite a few problems are still there in this exercise set, so we will finish this, and once we do that, we can then go to the actual things in calculus, because all these are preparatory elementary things. So there we would have limits and continuity of functions. So the next upload, the next video is on Friday, and Friday we will do group theory from Herstein's topics in algebra. So see you on Friday. Until then, this is me, Lucifer, from A Mathematical Room. Have a nice night.